Welcome, my friends. In this video, I'll begin my discussion of Chapter 8, Testing for Differences. In this video, I'll be covering Section 8.1, Designed Experiments. In previous videos, we've discussed the difference between an experiment and an observational study, but I think it makes sense to review it here. An observational study is where the researcher observes or questions the individuals without imposing any conditions on them. For example, a survey that asks subjects if and how often they exercise would simply be an observational study. We're not telling different people to exercise more or less, we're simply asking subjects if and how often they exercise. On the other hand, an experiment is where the researcher does impose varying conditions on the individuals in order to observe a response. For example, a study in 2007 randomly assigned overweight women into one of 4 diet groups to track their weight loss based on carbohydrate intake. The women were randomly assigned to one of 4 diet groups. 1, the Atkins diet, which is very low carb, the Zone diet, which is low carb, the Learn diet, which is low in fat, high in carbs, or the Ornish diet, which is very high in carbs and has limited animal products. What makes this an experiment is because the women did not choose which of these diets they wanted to be in. They were randomly assigned to be in one of these 4 diets, which is what makes this an experiment. In an experiment, the explanatory variable, aka the independent variable, is the variable the researcher would like to investigate to determine its impact on the response variable, aka the dependent variable. For the experiments we discuss in this class, typically the explanatory variable will be categorical, and the response variable will be quantitative. An experiment can show a causal relationship between the explanatory and response variable, but an observational study typically cannot. The reason is, in an experiment, we are randomly assigning individuals to the different treatment groups, and therefore that can eliminate the problem of lurking variables. For the diet study example, the explanatory variable would be diet group, which has 4 different options or levels: Atkins, Zone, Learn, or Ornish. The response variable might be the weight loss after 12 months. Here's what that looks like visually. We would like to see how the explanatory variable, or diet, has an effect on the response variable of weight loss after 12 months. Okay, so there's some other terminology we need to go over related to experiments. The individuals for which the response variable is measured in an experiment are classified as the observational units. So in the diet study example, each individual person is classified as an observational unit. Sometimes there could be multiple explanatory variables. So in the example we've already looked at, we said that diet was one explanatory variable, which had the 4 different options. But maybe we would also like to consider sex as male or female. Now, I know the original study said it was only for females, but let's just assume for the sake of argument here that we also have males in this study. Now, there's a very important distinction we want to make about our different explanatory variables. So if an explanatory variable is specifically imposed or controlled for or randomized by the researcher, then that's what we call a factor variable. So for example, the diet example in our study would be considered a factor variable because it's something that's specifically imposed by the researcher. The researcher is randomly putting individuals into one of these 4 different diet groups. So for that reason, we would say this is a factor variable. On the other hand, the explanatory variable of sex is not considered a factor variable as it is not specifically imposed by the researcher. And there really wouldn't be any way for the researcher to do that. We can't randomly assign the subjects to either be male or female. They already come to the study being male or female. So this is not going to be considered a factor variable. The treatments include all possible combinations of all factor variables. Now, if we only have one factor variable, like in this case, then the treatments would just be the 4 different options or all the different options for that variable. So if the only factor variable that we had was diet, then the treatments would be Atkins, Zone, Learn, and Ornish. But in many cases, you might have more than one factor variable. So let's suppose that the 2 factor variables are diet and therapy support. And for therapy support, we have 2 different levels or options, either getting therapy support or not getting therapy support. Now remember that a variable is only considered to be a factor variable if it's specifically been imposed or randomized by the researcher. So that means that therapy support would only be considered a factor variable if the researchers determined which individuals will and will not receive the therapy support. So let's assume that that is the case. We have the two different variables. We have the explanatory variable of the diet, which has the 4 different options. And we have the explanatory variable of therapy support, which has 2 different options. And we're going to randomly assign individuals to each of those, one of each of those groups, one diet and one therapy group. That means that there will be a total of 4 times 2 equals 8 different treatment groups that the individuals would be randomly assigned to. Where did I get 4 by 2? Well, there's 4 diet groups and there's 2 therapy groups. So if we multiply those together, we will find that there are 8 different treatment groups, which is basically the number of ways there are to mix and match a diet with a therapy. So here will be the 8 possible treatments that we would want to research. So we could basically have each diet either with therapy or without. So we have Atkins with therapy, Atkins without, Zone with therapy, Zone without. We have the Learn with therapy, the Learn without, and then we have Ornish with therapy or Ornish without. So we would kind of look at the results from our experiment and from there be able to tell potentially which of those categories is giving the best, the best result in terms of weight loss. And maybe we would determine that the therapy is not really having an effect, right? Maybe all the Atkins with therapy versus no therapy, maybe there's not much of a difference there, and maybe that's the same for the rest of those. We'd have to kind of analyze all this together to make our conclusions about the effect of both the diet and therapy. Okay, there's something else we should discuss that you're probably familiar with, which is called the placebo effect. So oftentimes if you have a medical experiment, you might have the following types of groups. So you might have one group which is going to receive the experimental medication that you were trying to see if it works, right? So you have this new medication that's supposed to cure this illness or disease or something, and that's really the main group that you want to test, right? You want to see if this experimental medication works. But you want to have something to compare that to. So we're going to compare that to maybe an old standard medication or maybe like a competitor's medication. But also we might have a third group which is going to receive basically no medication at all, but they're going to receive it in the form of a sugar pill or something we call a placebo. So all 3 of these groups, no one really knows which group they're in. They all just told they're kind of part of this study, which is studying the effect of a new medication. And they are all told to take this maybe pill, and they don't know which group that they are in. And they might not even know that there are 3 different groups. Now, the thing is that many individuals in that third group, the placebo group, may credit the placebo with curing their illness, or they may report that they got better, even though what they are taking doesn't actually have any active medical ingredients in it, right? Now, we use the term control group to really just refer to a group that we would like to compare to. So in most cases, the placebo would be considered a control group. You could also say group 2 here is somewhat of a control group because really our focus here is group number 1. We want to know whether or not this new medication is effective, and we want to compare that to maybe these 2 other groups. So group 3 would be maybe like your primary control group, but we also want to know how it's doing with respect to group 2. Typically, you're going to want to have this be a double-blind experiment, like I've already mentioned here, and that means that the researchers and the participants are unaware who's in any of these treatment groups. And that's just a way to sort of eliminate the bias. And finally, ideally, we would have what is called a completely randomized experiment, which just means that individuals are randomly assigned to these 3 groups. They're not self-selecting into one of these groups. They've been randomly assigned to one of these 3. Okay, a couple more definitions here. So we have an experimental unit, which is the smallest group of observational units in the study assigned to a treatment. And we think of a treatment being applied to an experimental unit. So remember, an observational unit is really just like the individual, like each individual that we're collecting information from. But sometimes the experimental unit could be the same as the observational unit, and sometimes it could be different. And I think the best way to explain this is just to give some examples here. So note, in many experiments, the experimental unit and the observational unit could actually be the same, because in many cases, we might apply the treatment to each observational unit individually. So consider a medical drug trial where the individuals are assigned to either receive a new experimental drug or a placebo. Well, in this case, the experimental and the observational units are the same. The treatment is applied to each individual, and we are also collecting the response variable from that same individual. So we are both giving each individual, either the drug or the placebo, and we're also collecting health data from that same person, right? So that means that both the experimental and observational units would be the same. But let's look at a different example where they might be different. So suppose there was a study where the water filtration systems were installed into homes that were known to have contaminated water. Health markers for the individuals in the homes are gathered before and after the installation of the filtration system. So now in this case, the treatment, which is the filtration system, is really applied to each house. But the health markers would not be collected from the house. They would actually be collected from each individual. So now we kind of have a difference here. The treatment is applied to one thing, but the actual response is collected from something different. So in this case, we're going to have a difference between the experimental and observational units. So that's what I'm stating here. In this case, the treatment of the filtration system is actually applied to the house, which is the experimental unit, or each house would be an experimental unit. That's what we're applying the treatment to. But the observational unit is what we collect the actual response from, which in this case would be the health markers, right? The observational unit is going to be each individual living in the home for which the health markers are gathered from. So in total, the experimental unit is what are you applying the treatment from? And the observational unit is what are you actually collecting the response variable from? Okay, let's take a look at some examples, and then we'll have a few for you to try, or maybe one for you to try. So here's number one. It says the owner of a Christmas tree farm wants to determine which of three fertilizers, either A, B, or C, is the most effective at stimulating growth. Each tree is randomly assigned to a fertilizer, and then after 7 years, the height of each tree is measured. So first we are asked, what is the response variable? Well, the response variable is what we're collecting right here, which is going to be the height of the tree after the 7 years of it growing. So the height of the tree is going to be our response variable. What is an observational unit? Well, the observational unit is what we collect the response variable from. It is going to be the individual tree. What is a factor variable? Well, the factor variable is the explanatory variable that has been controlled for by the researcher, which is going to be the fertilizer type. Right? So the type of fertilizer, either A, B, or C, which we said we're randomly assigning the trees to, that's going to be our factor variable. What are the treatments? Well, we only have one factor variable, so that means that the levels of the factor variable are going to be the treatments. It's just going to be fertilizers A, B, or C. Now, finally, what is an experimental unit? So experimental unit is what we actually apply the treatment to. And in this case, we actually apply the treatment to each tree. So they say each tree is randomly assigned to a fertilizer. So that means an individual tree is also going to be an experimental unit as well as an observational unit. The reason why it's observational is because that's what we collect the response variable from. The reason why it's experimental is because that's what we're applying the treatment to. Okay, so take a second and make sure that you understand all of these parts. And let's go on to the next example here, which is the same exact situation. But now in addition to the fertilizers, A, B, and C, the farmer would like to also experiment with using no fertilizer at all. So now we have this fourth group of no fertilizer. Also, there are 4 different types of trees being grown. We have Fraser firs, Colorado spruces, Douglas firs, and Scottish pines. I have no idea if these are actual trees. These are the trees that were used in the Grand Valley textbook for this example. So each fertilizer is applied to a plot of land that contains only trees of a particular type. So that's actually different than the previous example. In the previous example, we applied the fertilizer to each tree, and now the fertilizer is applied to a plot of land that only contains a particular type of tree. The height of each tree is then collected for this study. So then we're asked for a number of different things. So first, what are the 2 factor variables? So now we have the type of fertilizer, and then we also have the type of tree. So we're kind of like randomly determining the fertilizer and then also the type of tree. Now we have 2 different factor variables. How many levels are there for each factor variable? Well, we have 4 different fertilizer types. We have, either A, B, C, or none is another option here. So we would consider that as one of the possible levels there. And then we have the 4 different trees. So how many treatments are there going to be? Well, remember that treatments are the number of ways you can basically mix and match all of the factor variables. And you can find this by taking the number of levels there are for each factor variable and multiplying them together. So in this case, that's going to be 4 times 4. 4 fertilizer types times the 4 tree types, which is 16. Now it asks if there is a control group. What is the control group? And then does it involve a placebo? And you probably would consider the control group any of the trees grown without fertilizer. So there's almost kind of like 4 different control groups. We want to see how the no fertilizer compares to when we do use fertilizer. And it doesn't really make sense to have a placebo here because we don't really have human subjects. Now, what is an observational unit? And remember that the observational unit is what we collect the response from. And we want to know if that's different from the experimental unit. So think about that for a second. So the observational unit is going to be, we're collecting the height of each tree, so that's collected from each tree. So the observational unit is each tree. This is what we're collecting the height from. But then you have to ask yourself, what is the experimental unit? The experimental unit is what we apply the treatment to. And we are applying the treatment. I would probably think about this as, mostly collecting, focusing on the fertilizer types. The experimental unit is really applied to each plot of land. And that's what we're applying the treatments to. So the experimental unit in this case would be a plot of land. Now, if you're curious, here are the 16 treatments. So we basically have each fertilizer type paired with each tree. So A with the 4 types of trees, B with the 4 types of trees, C, and then we have the no fertilizer. Okay, so here is a problem for you to try. A study is conducted to see if exercise can help improve dementia symptoms. Subjects with early onset of dementia are placed into 3 groups. We have the walking group, the yoga group, and then we have no organized exercise. And after 3 months, the dementia symptoms are scored on a scale of 1 to 10 by a psychologist. So go ahead and see if you can do these things. What is the response variable? What's the observational unit? What is the factor variable? And then finally, what are the treatments? Okay, so pause the video and give that a shot. Okay, assuming that you have tried that problem, assume the same situation, but now individuals are also either given free weekly counseling support or not. And let's assume that they are like randomly assigned to either get this counseling support or not. So then go ahead and answer this set of questions. Okay, so pause the video and give that a shot. And then that is all I had to talk about in this video, so I will see you in the next one.